Welcome back, guys. In this video, I'm going to be covering the concept of stoichiometry. Now, stoichiometry is going to be very helpful in analyzing chemical equations and answering questions that have to do with calculating how much of something that we are going to produce. Now, how are we going to use stoichiometry to do so? Well, the first thing we need to do if we're going to use stoichiometry is to get a balanced chemical equation. Now, I made up this equation with these made-up variables. However, if we were dealing with a real chemical equation, we would need to make sure that everything was balanced on each side. And the way we do that is by adding these coefficients in front of our chemical structures, right? So these numbers are going to be very important, right? If there's nothing there, we understand that to be a 1, right? We call these our molar coefficients, okay? And it's really important that we have these molar coefficients labeled in our chemical reaction. And what these coefficients mean is this. If we were to run this entire reaction one time, 2 moles of A would react with 1 mole of B to produce 3 moles of C and 2 moles of D. Now, with that info, we can start at any point and get to a final destination using ratios between these molar coefficients. Now, what do I mean by that? If we have a practice problem where it asks if you react 1 mole of A, how many moles of C would form, we can use these molar coefficients to calculate the answer. So if we have 1 mole of A, okay, so imagine we had 1 mole of A and we want to react that mole of A, how are we going to find out how many moles of C form? Well, at this point, we're going to use stoichiometry. So we're going to say every time this reaction runs one time, we have a ratio of 2 moles of A reacting with 3 moles of C. Okay, and the moles of A are going to cancel out and we'll be left with 1.5 or 3/2 moles of C. Okay, so stoichiometry, you get your balanced chemical equation, right? And you can use the molar coefficients as ratios to determine how much of something you're going to produce from a given starting material or starting info. Okay, so let's tackle practice problem number 2. So it asks, if you react 40 grams of B, how many grams of D would form? Now, if you're given a problem like this, you want to make sure that you're in moles, right? So they give us 40 grams of B. Okay, now grams does not help us, okay? Because we need to be in moles to use these molar coefficients for ratios. So what I want to do is first get this gram value into moles, okay? So the molar mass of B, right, we know we have to divide by the molar mass to get to moles, okay, is 12 grams for every 1 mole of B, okay? So now we have successfully got moles of B. Now at this point, we're going to use stoichiometry because every time this reaction runs once, we are going to react 1 mole of B, okay, for every 2 moles of D that we're going to produce. Okay, so for every time we run this reaction, right, we have 1 mole of B reacting to produce 2 moles of D. However, we need to get grams of D, okay? So our last step is 1 mole of D is going to be 14 grams. Okay, so if we take 40 divided by 12, then multiply it by 2, then multiply it by 14, we get 93.3 grams of D. Okay, so for stoichiometry, we need a balanced chemical equation, right? It's very important that you balance it correctly and you get these molar coefficients labeled, okay? If you have moles, you can use a mole-to-mole ratio, right? This is your mole-to-mole ratio, okay? And if you have grams, you want to make sure that you're getting to moles before you do your mole-to-mole ratio, right? And solve any problem from there. So hopefully you enjoyed this video and make sure to check out more on the channel.